Hey everyone! Today we're gonna talk about crystals and explain some cool stuff about them. I'm Rasam.
And I'm Ogi, and this video is a project for our grade 11 chemistry class in Forest Hill Collegiate Institute, Toronto, Canada.
When you hear the word crystal, the first thing that comes to your mind might be this, or even this. Many people think that crystals are special rocks that have beautiful colors and nice shapes. But what does the term crystal actually mean? A crystal or crystalline solid is any solid pure substance whose atoms or molecules are arranged in a highly ordered and geometrical structure. An example of a crystal could be table salt, a snowflake, or diamond. Well, you might think that table salt doesn't have a geometrical shape, but when you look at a grain of salt under the microscope, this is what you actually see, a perfect cube.
So, a crystal structure can be thought of as a box containing one or more ions, molecules, or atoms together in a special spatial arrangement. These structures or unit cells are held together in a three-dimensional order forming a crystal. The unit cells forming a crystal are stacked together with no gaps in between, creating a perfect symmetry of a crystal. However, there are three main types of the unit cells arrangement. Beside already mentioned crystalline structure, there is an amorphous structure as well. The key difference between the two is that the crystalline structures are composed of basic unit cells arranged in a repeating pattern, whereas the amorphous structure lacks the property of a crystal lattice. The amorphous order of unit cells is always random and irregular. Therefore, the amorphous structure belongs to the group of non-crystal structures. The most known structures of this kind is glass, which is a solid structure lacking the consistency of a crystalline pattern. Other examples are film lubricants, metallic glasses, gels, and polymers. There is also a third type of the solids known as a polycrystalline or multicrystalline structure, composed of many crystallites of varying sizes and orientation. It belongs to the group of crystals since it has a repeating pattern. Examples of these are rocks, ceramics, common metals, and ice. Crystal structures are like a bunch of atoms, ions, or molecules located in specific areas of the box. The atoms represent the repeating group of a repeating unit cell with the same connectivity in the compound. The arrangement of the atoms is always unique and is fully related to the natural properties of the compound, meaning there will be no two exact same-looking crystals. Crystals are often recognized by their shape. When people think of a crystal, they often have in mind a flat faces with sharp angles on top. That is, however, not always necessarily true. What defines whether something is a crystal or not is its microscopic arrangement of atoms. However, the macroscopic look is what people see and therefore make wrong assumptions. So there are two divisions in terms of the microscopic and macroscopic look of a crystal. On a microscopic level, crystals can be arranged in 219 possible crystal symmetries called crystallographic space groups. These groups can be further divided into 7 major crystal systems. The first one would be a cubic or isometric system. The second one is a tetragonal shape. The third one would be orthorhombic shape. The fourth one is a hexagonal shape. The fifth one is a trigonal shape. The sixth one would be a triclinic shape. The seventh one is a monoclinic shape. When speaking of their macroscopic look, crystals can be euhedral, the ones that we are most familiar with, and anhedral that are not as common to us, mainly because the crystal is one grain. Crystals are mainly found in rocks in terms of their volume and weight. They often differ in size from a fraction of a millimeter to several centimeters across. The largest naturally occurring crystal is a crystal of a beryllus, and it's found in Madagascar. It's 80 meters long and weighs about 380,000 kilograms. Some crystals are formed by magmatic and metamorphic processes. Other rock crystals are formed as a precipitate from fluids. The example is often the water that forms druses and quartz veins. Ice is also a very common example of a crystalline or polycrystalline structure. An example is a snowflake as a single crystal, while an ice cube is a polycrystalline. There are also types of organigenic crystals. Calcite and aragonite are minerals made of calcium carbonate and are produced from mollusks, while hydroxylapatite are produced from vertebrates.
Well, now we know what is a crystal and how it appears in nature. But how does a crystal form? Crystal formation can be achieved by various methods, such as cooling, evaporation, or a technique known as anti-solvent. But no matter what method is used, crystals form through a process called crystallization. This process can occur in one of three major ways: formation of a crystal from a liquid, a gas, or amorphous solid. In order for crystallization to take place, a solution must be supersaturated. Supersaturation refers to a state in which the solvent contains more dissolved solute that can ordinarily be dissolved at that temperature. The supersaturation is the driving force under whose influence new crystals are formed and present crystals grow. That's why all crystallization processes are aimed at creating a supersaturated solution or melt. Crystallization has two fundamental stages, one, nucleation, and the second is growth. In nucleation, the atoms or molecules arrange in a defined and periodic manner that defines the crystal structure. Crystal structure is a special term that refers to the relative arrangement of atoms or molecules, not the macroscopic properties of the crystal, which is the size and the shape, although those are a result of the internal crystal structure. Nucleation can occur in two different ways, the first one being the primary nucleation and the second one is secondary nucleation. Primary nucleation is the initial formation of a crystal where there are no other crystals present, or if there are crystals present in the system, they do not have any influence on the process. Secondary nucleation is when crystal growth is initiated with contact of other existing crystals or seeds. The last stage is growth. Growth is an orderly addition of further molecules of ions in a regular manner. The crystal owes its shape to the orderly arrangement of atoms which compose it. The symmetry of the crystal shapes is their most recognizable feature. To observe and see how crystallization works, I tried to grow the crystal of copper-2 sulfate using the cooling method. The tools that I used were two beakers, a beaker tongue, a hot plate, a mortar and pestle, a piece of very thin rope, and water. I also used a filter paper and a funnel, which are not in this picture. For this experiment, first I boiled the water using the hot plate and grinded copper-2 sulfate into a powder using the mortar and pestle. Then I dissolved the powder in the water and made a supersaturated solution. Afterward, I filtered out some impure substances and a small amount of copper-2 sulfate which was not dissolved in water. Finally, I tied one end of the rope to a pencil and put the other end in the solution and left it until the crystal was formed. This is the final product of my experiment. In this experiment, the growth of the crystals is caused by the solubility of copper-2 sulfate in water at different temperatures. As the temperature of water decreases, the solubility of copper-2 sulfate in water decreases as well. Therefore, when the supersaturated solution with high temperature starts cooling down, copper-2 sulfate molecules start precipitating since the solubility decreases as the temperature decreases. While the copper-2 sulfate molecules are precipitating in the solution, they arrange themselves in an orderly manner, making the nucleus. And when the nucleus is formed, it further grows into a large crystal.
The crystals are used for a variety of different purposes. Most of us are familiar with crystals being used as a jewelry or ornaments that are part of the decoration. However, there are many other as equally important uses of crystals. One of them is their importance in the healing industry. Some people believe that crystals are capable of encasing the body's healing abilities and reducing stress. Other people think certain crystals correspond to certain chakras in one's body, helping them bring the balance to their minds and souls. They are also used as a part of a meditation in order to help the body in a spiritual way. However, not do only people nowadays find the crystal extremely useful and practical, but ancient civilizations do so too. Starting with the glorious Roman Empire, back in the time, crystals were used to make amulets or protective talismans that were used to attract good health, fortune, or prosperity. Crystals also found their use in Chinese medicine by being used in a form of crystal-tipped needle, mainly serving a purpose of acupuncture. They served many different purposes in cultures such as ancient Greece and India as well. That would be all from us, and thank you for listening.